Assalamualaikum friends, welcome to my new video. It is basically related to direct shear. The direct shear test is mostly suitable for sandy type materials and it is also conducted on clay type materials. So this test will provide the two parameters C cohesion and phi friction angle. C is the basically property of the clay type material. It is the force of attraction between the clay particles when water is added. So there is produced charge positive and negatives, so it will attract, so this property is produced that way, while the friction angle is the basically the interlocking between the particles. So more is the angular particle, then higher will be the friction angle. So this is the basically the shear strength formula by shear strength by coulombs, which is the S equal to C cohesion. This is the basically total stress, tangent phi friction angle. This is the direct shear digital apparatus. This is the shear box in which sample will be placed. This is the place where loads, all loads will be placed, 50 kPa, 100 kPa and 200 kPa. This is the display showing the horizontal and um, force, shear force values, balance required for the test. This is the ring basically required for the undisturbed sample preparation. This is other apparatus are the spatula, wash bottle and china dish for the sample preparation. So there is a point related to the loading condition. Uh, as the total stress is equal to basically our sample is placed under the ground, for example at that location. So total stress will be equal to, this is the depth, and this soil may have some unit density. So this unit density multiplied by depth, it will be the total stress. So again total stress is the sum of basically the effective stress plus pore water pressure, but in this test pore water pressure cannot be found out, so the total stress will be equal to effective stress. So this is the basically sample preparation for the disturbed sample. As from proctor test uh, we find out the MDD, maximum dry density, and OMC percentages. So as we know that from the dimension of ring we can find out the volume of the ring. So here again same formula, gamma is equal to W by V, which is the basically the most common formula. So here we are finding the weight of the sample. So weight will be, which is the gamma MDD multiplied by volume of the ring, which is basically this calculation. So from this calculation this will be the weight of the soil. So and with that weight of soil you multiply by 10.5%, so this will be the weight of water required for the soil. You need to mix it thoroughly and then put into the shear ring that I showed in the apparatus, and you need to put it in three layers and completely fill it. So I also find for the 95%, because most of the time you are at site you are using 95 to 90% densities for the soil type material. This is the basically the procedure for the test. You need to completely clean the shear box assembly, then you need to place the porous disc under the sample, then you need to shift prepared sample, shift the prepared sample into the shear box. Then you need to place that shear box into the loading assembly. Put the load for 50 kPa, then run the test, and after that is test is complete, trial is complete, then you need to put the other sample at the same density NDD and OMC, put the 100 kPa weight, run the test, and so on also for the 200 kPa. So the in case of sand, you need to directly mix the weight of soil with the weight of sample with the OMC weight of water, and mix it, and then you need to directly put into the shear box. So you need to put the speed around 1 mm per minute. This is the basically sheets and graphs showing the result I conducted on the type of sample. This is the horizontal displacement. This is the shear force values recorded on the from the screens. So as you can see that for 50 kPa, this is the 50 kPa line, the maximum peak is around 38.3 kPa shear stress. Similarly, for 100 kPa, the peak is around 74 uh, kPa and 8.5 mm displacement. While in case of the 200 kPa, the peak is around 9 to 10 horizontal mm displacement, and the shear stress value is around 142. So these are the maximum values attained on each stress. So this is the basically graph between shear stress, and this is the normal stress. What is the normal stress? Normal stress is the basically the loading that are put on the clamps, and this is the basically the shear stress values which are found by dividing the uh, force value divided by the area of the segment, by which these all shear stress values can be found out. So after that you achieve that graph, you need to extend that graph, and for example it touches that point. So at that point the value is around 4.3 kPa. So cohesion is around 4.3 kPa, and friction angle can be found by uh, tangent inverse into the, as you can see here at on vertical axis we have shear stress values, and divided by the normal stress values. By that way you can find out the friction angles. So this is the basically schematic illustration of the test by how are these reading are recorded. We have attached a horizontal displacement gauge as well as the force measuring gauge. So all these readings are noted down on these gauges. So there are three conditions at which you need to stop these tests. First is the load reaches the peak, and then start decreasing. Second is the load reach the peak and remain constant. In our cases, load reaches the peak and then remain constant in all cases. So, and the third point is the deformation of the specimen past 20% strain before reaching the peak. This is most commonly found in the high plastic type soil. So what is the advantages of this test? test is very easy and faster. Disadvantages is that the most of the time failure is always along the horizontal plane. No correction on the sample area are considered. In case of larger particles, C cohesion and friction angle can be overestimated. No pore water pressure is considered during this test. So this is the basically the direct shear test procedure which I explained. So this is the uh, most common test used for the finding the C and phi method. Another method finding the friction in C is the triaxial method, but it is more complicated because it also record the pore water pressure values, and that setup also required many specialities. So that test is basically difficult to difficult and most commonly used in cases of dams. So thank you for watching my video, and like my video and subscribe my channel. Thank you.